Welcome folks here to the soil pit here at the MBFI farm today. My name's Curtis Cavers. I'm an agronomist with Agriculture Canada, Agriculture and Agri-Food Canada, but also doing some PhD work with the University of Manitoba with Dr. David Lobb, and Michelle Erb is my colleague here today, the one that knows what's going on down here. I'm just here to provide comment and sarcasm and hopefully maybe invoke some questions in that too. But Michelle's with Manitoba Agriculture, and let you describe what your position is and
Sure.
what we've got there with us.
So I work with the province. I'm an agricultural planning specialist. So most of my work involves looking at the soil in terms of its agricultural capability, and then assessing various land use proposals that are put forward by municipalities. Actually, so I'm very much, it's partly policy, partly interpreting soils maps, looking at land use, wanting to make sure that we keep protecting farmland for farm use. But once upon a time, in a former life, I did work for the province as a soil survey specialist. So I spent some time in the Arm of Elton conducting soil survey. And I also, when I worked on my master's degree, my research was conducted here at the farm when it was formerly the Zero Till Research Farm. So that's my background. I'll jump right into the big reason for a soils tour is to jump in the pit, right? We're all here to learn about soils. We heard some our talks this morning were talking about characterizing soil organic carbon, soil organic matter. We talked about looking at, above ground biomass and contributions to phosphorus. Now we're going to jump in and we're going to look at characterizing the soil. What are the things that we look at when, trying to determine what type of soil we're standing on, we're trying to farm. So a bunch of different things. We can get into the CLORPT, the soil forming factors, but sometimes we just want to jump right in and start looking at things. When we're doing a soil survey, we want to try to make sure that we're getting representative, sample sites across the landscape. We're at the Zero Till farm here. We're in the Prairie pothole region. We have gently sloping landscapes. We're situated right here, I would say roughly about mid-slope. Luckily, the pit is long enough that we're moving down. The slopes are somewhat shorter here. We're moving down slope. So we get a great opportunity of looking at how soil can vary across a landscape. I'm standing in front of the profile. We did do some characterization here in advance of the tour, but when we dig a soil pit, we're looking at changes in horizons. And as you can see here, we've got a pretty thick A horizon. What I was really, I can't say that I've dug a lot of pits in a forage, like a perennial field. Mostly we're digging in, annual cropland. So it was really impressive for me to see, the thick AH horizon. We've got quite a bit of organic matter, like almost an O horizon on top of our mineral soil. And then we've got a really thick A horizon here, in the 20-25 centimeter mark. So I think that I'm trying to gather my thoughts here.
You're dealing with a lot of topsoil, fairly thick topsoil.
Yeah.
You've got kind of a typical soil profile and its arrangement. In fact, this is our provincial soil. For the real keeners on this, the New Dale is our provincial soil. So the idea is that a representative, typical soil of what you kind of see in certain parts of the province anyway. It's a black soil. We don't have many brown or dark brown soils compared to Saskatchewan and Alberta. It's a grassland soil, things like that, and it's a very productive soil. It's not necessarily our best soil, but it's a very good soil. And we'll talk a bit about that when we start getting into ag capability.
So we jump right into the pit. We look at what the horizons are. And part of what we would expect, I guess it's a matter of, those soil forming factors are pretty important. Like from a producer perspective, you might not be too concerned about, why we're seeing what we see. But when we're thinking about the landscape, we're looking at, how water, this year water is obviously on mind, at the top of mind, because the lack of water, more water here, surprising than where I'm coming from. The Red River Valley is very dry there, but water is a very important factor when we're looking at soil profile development. In these sloping landscapes, we have a certain amount of water runoff, but we also have water moving through the profile, and that's what really lends to this horizon development. So the more water moving down the profile, you start having organic material moving through the profile. We have clay that at times can enrich the B horizon, and then also carbonate. So trying to determine, are we looking at a soil that is affected, is it well drained? Is it imperfectly drained? We have a handy hydrochloric acid, not something that most producers would have in their back pocket, but in the field,
certainly not in your pocket.
No, not in your pocket. So in the field, we use a dilute hydrochloric acid solution to tell us a little bit about water movement through the profile in terms of where the carbonate is occurring. So some of our soils will have carbonate content right to the surface, telling us that there hasn't been a lot of downward movement. We know that calcium carbonate can dissolve in water, so water will move that through the profile. In this case, we don't have carbonates near the surface.
It's not doing anything.
No.
You sure it's acid?
and we don't expect to see it in a well-developed B horizon. Sometimes you even have to listen. It might be such a weak reaction that you don't really see it, but you do hear it. But we don't. Trust us. It's not in the B horizon here.
I trust us. That's the main operative.
And then as you move down the profile, you do start to see, I don't know if anyone else can see that, but it's a pretty,
back there?
quite a bit of reaction occurring. And then as you move even further down the profile, if you take a piece of this here, it's okay. It doesn't burn. We really get a lot more effervescence, and then I was finding that I was questioning whether or not we might have an accumulation of calcium carbonate sort of in this sort of range here, because I was finding that there was a lot more. So that was the parent material beneath that really fizzy layer, and so it was less reactive than what we are finding in the CCA. And what that's just telling us is we're getting an accumulation of calcium carbonate in moving down, and then also possibly some moving up with water as the water table fluctuates.
And
so
choreography.
And what else? So another thing about the Newdale, this is a till in terms of parent material. It was deposited as glaciers receded, and so the evidence of that is the presence of gravels throughout the profile. Less so towards the soil surface, but we would describe this as having till throughout. And that's right. It's a mix of gravels. So you have your limestone, shale, granite deposits, and what else? And that would compare to, say, lacustrine or fluvial deposits.
So lacustrine would be like lake bottom.
Lake bottom, so Red River Valley, yeah. Fluvial is often, it might be coarser materials, on the edges or near fast-moving water. And then we have the deltas, so the sands that are the beach edges of the former glacial Lake Agassiz. And so those are more uniform sands. And then you can have sort of a mix. You can have sands over top of clays. You might have some stratification of till over lacustrine over till. It just all depends on how that soil was deposited as the glaciers receded. What else?
Texture.
Oh, texture. Texture's the best part. So if anyone wants to get their hands dirty, we have some water to clean and paper towels and sanitizer. We can pour, so when you're in the field, obviously when you're conducting a soil survey, you're going to take samples and send them off to the lab. We know that soil texture is comprised of